Hi guys, so I know we ran out of time at the end of class and I wanted to make sure that everybody got number 15 explained to them because this is going to be 8 points on your test. 8 points out of 40 is 20%. So you need to make sure that you're comfortable with this question. So number 15 says the Garncar's family started savings accounts for their twins, Avery and Lizzie, on the day they were born. They invested $6,000 into an account for each child. Avery's account pays 5.1% annual interest compounded quarterly. Okay, so we're going to have to use the compounded K times per year formula. And then it says that Lizzie's account pays 2.9% annual interest compounded continuously. So if it's compounded quarterly, we're going to be using A equals P, 1 plus R over K to the KT. And if it's quarterly, our K is going to equal 4. Now for compounded continuously, it's A equals PE to the RT. Okay, so these are the two formulas that we're going to be plugging into. So now the next part says write a function A of T for Avery's account. So we don't want it to be A equals, we want it to be A of T equals. Now P is the principal, the amount that you invested, and they invested $6,000. 1 plus, the interest rate is 5.1%, so if we divide that by 100, we're going to get 0.051. We said K was 4 because they're compounding it quarterly, so 4 times per year. And then that's going to be to the 4t power. Okay, so there's the formula for Avery. Now for Lizzie's formula, they want us to use L of T. So it's not going to be A equals, it's going to be L of T equals. And we're using A equals PE to the RT. So P is still 6,000. That's how much they're investing. But then it's going to be the natural number E. So that's a constant in our calculator. The R is 2.9%. But remember, you have to divide that by 100. So it's going to be 0.029 T. Okay, so those are the two formulas. That's going to get you 2 points right there. Now it says determine who will have more money in their account when the twins turn 17 years old and find the difference in the amounts and the accounts to the nearest cent. So if we're going to have to find the difference, we're going to have to subtract when we're done. So first thing I want to do is I want to figure out how much Avery's going to have after 17 years. So I'm just plugging in a 17 for the T, so it'll be to the 4 times 17 power. Okay, we're going to type this right into the calculator. Now my calculator is going to look a little bit different than yours, so don't worry about the buttons I'm hitting. All right, so it's going to be 6,000, 1 plus 0.051 over 4 to the 4 times 17. Okay. And this is money, so we're rounding it to the nearest cent, which is 2 decimal places. So she'll have $14,200.52. Since that next number was a 4, I'm just going to drop it. So that's how much money Avery has after 17 years. Then I'm going to do the same thing for Lizzie. So I'm plugging in a 17. I'm going to type that into the calculator. So it was 6,000. And then it was E to the 0.029 times 17. And we got $9,823.32. Okay, same thing, that next number after the 2 was smaller than 5, so we just let it go. All right, so now we know how much each of them has, but they wanted us to find the difference. So now I'm just going to subtract those. So 14,200.52 minus 9,823.32. Oops, I forgot my minus sign there. Try that again, but I'll actually press minus. Minus, there we go, 9,823.32. And we get $4,377.20. So Avery's gonna have more money, right? Avery will have $4,377. I'm not gonna leave it as 0.2 because that doesn't look like money. I'm gonna make it 20 cents. So she's gonna have that much more when they turn 17. All right, but now we have another portion. Determine how long it will take Avery. So we're using Avery's equation to triple her money. So I'm gonna start by just copying Avery's equation. I get to cheat a little bit. Whoops, maybe not. Won't let me screenshot that. Okay, so I'm gonna rewrite it. All right, so here is Avery's equation that we're starting with. And it's gonna be to the 4t. Now we wanna know how long. We're solving for time, and time is in the exponent, which means, you guessed it, we're gonna need logs eventually. Now they wanted her amount to triple. She's starting with $6,000. So we want the final amount to end up equaling $18,000 because that's going to be 6,000 times 3. Now, some of you like to skip over that part because when you divide by 6,000 on both sides, we know we're going to get 3 because that was the whole idea that we picked 18,000 because it would triple. So that number should be 3. So I know sometimes some of you just start with the 3 equals and then this expression right over here. So that's our exponential piece, the base to the power. So now that we have some power or some base raised to some power, we can convert it over to logs. So I'm going to circle the base, and the base is this whole big mess right there. Okay, so it's going to be log base 1 plus 0.051 over 4. Now what are we taking the log of? Remember, you always have to travel around the equal sign. So we're taking the log of 3, and that should equal the exponent, which is the 4t. Now, me particularly, I usually type this in with the divided by 4 right away. I feel like most of you like to type this left side into the calculator to get a decimal, so I'll do it that way so that it matches what you're most likely to do. All right, so same thing. My calculator is a little bit different, so it's going to be the same thing, but the buttons are located in a little bit different spots. So it's log base 1 plus 0.051 over 4, and we're taking the log of 3. Okay, so that gives us this decimal, 86.7138. I'm not going to write it all down. I'm just going to write ... so that they know that I know that it keeps going. And then I'm going to divide both sides by 4. All right, and we get 21.678 ... So let's see what they asked us to round it to. They said round it to the nearest 10th of a year. So that 7 is going to make me bump that up. So the time is going to be 21.7 years. And there you go. All right, so make sure you're comfortable with this because this is going to be worth a significant chunk of points on your test. So if you leave this question blank, the highest you can get is an 80 if you get everything else right. So it is important that you are answering this, even if you're not totally sure about every single part of it, lots of partial credit, so don't leave anything blank. And most importantly, make sure you know these formulas. All right, if you don't and you remember like a different formula, just get something on the page. Because if you have formulas in this first part and you plug into your formulas for the second part, I could at least give you credit. So like I said, don't leave anything blank. Fake it till you make it if you have to, but please make yourself comfortable with those formulas. You can, as soon as you come in tomorrow, you can write those down first thing while it's fresh in your mind. And good luck, everybody.